We've already looked at these three circle theorems, and we're going to add one more in. So let's talk about a perpendicular bisector of a chord. So the perpendicular bisector of a chord is the line that cuts the chord in half at a right angle. So if we have a circle and there's a chord, now we're going to take a line all the way through the center. Okay, so this is going through the center. And what this is telling me is that it bisects this line, so it cuts it into two equal pieces. So let's just say it's going through the center. So going through the center, cuts it into two equal pieces, and it meets at 90 degrees. So in other words, what we can see here is that we have a radius, and it is bisecting, so cutting the chord into two equal pieces at 90 degrees. So think about a radius and a chord. They meet at 90 degrees. And it also cuts that chord into two equal pieces. Now I keep saying that and reminding you, but that is the key fact here. Again, another example. So if we take a line all the way through the center, so here, there's my center, my rough center, very rough center. I'm going all the way through that chord. We're meeting that chord at 90 degrees, and you're splitting the chord in half. So now, these are all of the facts in circles that we need to know, and we've added this one up here. So let's look at an example of how this would be useful for us. So here we have a question. The chord xy, so xy, is 10 centimeters from the center of the circle. The chord measures 18 centimeters in length. What is the radius of the circle? So we know that this whole chord is 18 centimeters. So that's what we know. And we also know that the chord is 10 centimeters from the center of the circle. So from the center to the chord, that's going to be 10 centimeters. And we want to know what the radius of the chord is, so we want to know this. Now, if we go back and look at our important information, well, we know that the radius is bisecting the chord, so it's splitting it into two equal pieces, and it's meeting at 90 degrees. So if you can see here, we have a few triangles now, right angle triangles, and that's what we can use to help us find the radius. So if we take this triangle out here, and we make it bigger, so triangle XMO, we'll see that we're going to write down all the information we know from here. So this is 9 centimeters. Now how do we get 9? Well, we knew this whole chord was 18, but we know that the radius is split it in half, so each of these are going to be 9. So we know XM is a length of 9. We already know that OM is 10 centimeters, and we're trying to find OX, so we're trying to find that radius. Now here, we also know that this was a 90-degree angle. So we have a right angle triangle, and to find a missing length in a right angle triangle, we're going to use Pythagoras. So a squared plus b squared equals c squared. We're going to take my two shorter sides. This can be my a, this can be my b, and this will be my c. So square my 9 plus my 10 squared equals c squared. Add those together, and then I'm going to square root to get c. So this length here is 13.45 centimeters. Here's a question for you to try. Pause the video and press play when you're ready. So in this question here, AB is the chord with center O. So AB is my chord with center O. It makes a triangle. The radius of the circle is 5 centimeters. So we know that the radius is 5 centimeters. So from the center to the edge, from the center to the edge, center to the edge, right? So we have 5 centimeters here, here, as well as the long one. AB measures 8 centimeters. So this whole chord, AB, is measuring 8 centimeters. But we know that this radius is splitting this chord in half. So that means each of these will be 4. We also know that it splits it at 90 degrees. So if we take this triangle out, so we want to find the distance of OM. We put all the information we know in. So we know that was 5. Here we have 4. And we're trying to find OM. And using Pythagoras, so this is now a shorter side. So we square them, subtract them, and square root. And that gives us 3 centimeters. So OM is 3 centimeters. Right, on to one last question for you to try. So question 3. Pause the video and press play when you're ready. So we have the line OM is a perpendicular bisector of the chord CD. OM is 3 centimeters long. So O to M is 3 centimeters long. The radius of the circle is 13 centimeters. So my radius now is 13. So the radius centered to the edge, center to the edge, center to the edge. So it's 13. How long is the chord CD? So C to D, we want to know this whole length. So we know that this radius splits the chord into 2 equal pieces and it meets it at 90 degrees. And what we're going to do is we're going to take one of those triangles out and we're going to use Pythagoras to work out our missing information. So we'll write down all the information we know. So we know CO is 13 centimeters. We know OM was 3 centimeters, but we don't know CM. So using Pythagoras' theorem, we can get our missing length to be 12.65. However, we know that that is only one of them. That's only CM, and we wanted to find the length of the whole chord C to D. So all we have to do is then double that. So we are going to take this 12.65, we're going to double it, and then when you do that, so 12.65, and we're going to double it, we're going to get 25.3. So 25.3 centimeters. That is the length of the chord.